we're going to talk about how to correctly interpret PLC and DCS symbols on a P&ID. Before we get started, you might want to review two of our other videos called How to Read a P&ID and What is an HMI. You can find the links to these videos in the description. Alright then, let's get started. Anybody, such as instrumentation and control engineers, technicians, and maintenance personnel working on industrial plant control systems, depend heavily on P&IDs. A P&ID is like a roadmap telling us what the instruments and devices are, where they are located, and how they interact with the rest of the plant. Original symbols and terminology for P&IDs were created long before the introduction of PLCs and DCSs in plant control. Before computers came along, process control loops were standalone. In other words, each process had its own individual control loop. Control loops were massive. It had sprawling control panels with lots of controllers and other devices, such as strip chart recorders and switches. Today's industrial processes are controlled by computerized systems using virtual controllers found in PLCs and DCSs. In control rooms are filled with HMIs and keyboards connected to a DCS or PLC system. All of this computerization required that new P&ID symbols had to be developed. So let's look at the P&ID symbols for PLC and DCS. If you recall, standalone instruments are indicated on a P&ID by a circle with a tag number. The horizontal bar across the middle of the circle indicates the physical instrument resides in a primary location accessible to an operator on the main control panel. If we take that same symbol and draw a box around it, it now means that it is no longer a physical instrument. It is now part of a shared display and shared control in a DCS. Okay, let's look at a P&ID with DCS symbols and see how it links field instruments with the DCS and how it's displayed on the operator HMI. LT501 and FT501 are two field instruments, both sending electrical signals to DCS controllers. Let's take a closer look at the flow control loop. Flow transmitter FT501 sends an electrical signal to the DCS flow indicating controller FIC501, which in turn sends an electrical signal to operated flow control valve FCV501. Here's what the operator sees on the HMI screen. We put a big red circle around FIC501 and FCV501. As we discovered on the P&ID, the controller FIC501 is part of the DCS. FIC501 controller functions can be adjusted at the HMI by the operator. All FIC501 inputs and outputs can be observed in real time on the HMI as well. Okay, let's drill down a bit deeper and look at how the P&ID relates to the flow loop diagram. We place green circles around FT501 and FIC501. Referring back to the P&ID, you'll see that FT501 is a flow transmitter in the field, and FIC501 is a shared control in the DCS. This is a good time to point out the blue circle around the software signal lines, as they show how the DCS connects with the HMI. PLC symbols don't show up on P&IDs nearly as often as DCS symbols, but when they do show up, they are drawn as a diamond inside a box. All you have to know is that the symbol represents a software instruction to perform some function in the plant. For example, let's revisit our P&ID. The PLC symbol indicates that the SPV503 valve is operated by the emergency shutdown software instruction written in the PLC program. Let's review what we've discussed today. DCS and PLC symbols became a necessity with the computerization of process automation. If you see a square box drawn around a circle on a P&ID, that means that DCS is part of the control process. If you you see a square with a diamond in it on a P&ID, that means a PLC is part of the control process.